Good afternoon, students. Today we'll be discussing about Unit 2, that is nothing but water and its treatment, which is part of our engineering chemistry. Okay, my name is Anupam Kumar. So, Unit 2 deals with water and its treatment. And as we can see here, there is plenty of water that is flowing in the form of a stream. Plenty of water that is flowing in the form of a stream, and this is a part of our nature. And we will see how this plenty of water that is distributed. And before that, we can see that this picture is an enthralling view. It's a stream of water that is flowing on the surface of earth. It's a small stream of water, maybe that is going to merge into a very big river. Okay. Now here there are a lot of plants and other material that is nothing but rocks. Okay, and it forms an enthralling view on planet Earth. Now we can see here that in this slide the distribution of water. Okay, so water is this is the pie chart. This is here we can see that majority of this thing is nothing but water. Majority of this thing is nothing but water. And we can see that this is 71% of this is water. And here we can see that this is only 29% of it is land. Okay, we are seeing that this is completely water, 71%, and this 29% is nothing but this is 29% is nothing but this is land. Now here we are going to the next slide, and we can see in this slide that how Earth's water is distributed, how Earth's water is distributed in various forms. Okay, so this block indicates that this is nothing but Earth's water, and we can see here that this water is nothing but it's 97%. This water is nothing but 97%. And here we can see that it's Earth's water, meaning saline water. I mean saline water. It is very important. Out of 100% of Earth's water, 97% of Earth's water is in the form of oceans and seas, and it is completely saline. And its ppm will be around greater than 30,000 ppm. Okay, it's very high ppm and it is very saline water. We will not be will be unable to use it for drinking and washing purposes. Okay, like that it is. Now that is how Earth's water is there. Now let us go to the fresh water. Nothing but 3% of the 3% of it is fresh water. Out of 100%, 97% is saline water, and the rest is nothing but the 3% of it is nothing but fresh water. Okay, 3% of it is nothing but fresh water. Now this 3% of fresh water is present like this. Okay, this 3% of fresh water is present like this for us. We are having that 3% of fresh water. Okay, very important. We are having that 3% of fresh water is there. And now the 3% of fresh water, how it is distributed. The 3% of fresh water, we can see here that polar ice caps and glaciers. Okay, these polar ice caps and glaciers are nothing but the polar ice caps and glaciers that are present in Antarctica and very cold regions of North Pole and South Pole. Antarctica is nothing but the South Pole, North Pole is nothing but the Russia, very cold regions of Russia, and all these things will have polar ice caps and glaciers. Very, very big glaciers will be present, and these glaciers will be around 68.7%. Okay. So now out of this, these are nothing but polar ice caps and glaciers. Now we are having another 30.1% of it is nothing but groundwater. Okay, which is distributed in the below our Earth surface. It is nothing but 30%, and it is nothing but our groundwater. And now in first slide we have seen that very beautiful stream that is flowing on the surface of the Earth, and that is nothing but that kind of water corresponds to around 0.3% of it is surface water. Okay, and we are able to see here that this is nothing but other 0.9% is nothing but the other water, means the water vapor that is distributed in atmosphere, and the water vapor water that is present, that is already, that is getting precipitated, and it is in the form of clouds, and all this is nothing but the 0.9% of water is distributed in that form. And here how 0.3% of water is distributed, we are able to see here how 0.3% of water is distributed. We can see here very clearly that the 0.3% of water, how it is distributed. 87% is in the form of lakes. Okay, these lakes are flowing in the first slide. We have seen that what stream of water flowing in the form of a very big canal, and that very big stream of water is going to form a very big lake. Okay, so the lakes are around 87% of it is a lake. Swamps is around 11%, and the rivers is around 2% of it is or rivers. We are able to see rivers everywhere. We can see rivers and lakes and all these things everywhere. And it is like this: lakes 87%, swamps 11%, rivers is nothing but 2%. This is how fresh water is distributed on the surface of the earth. Now, water on earth is there, very important. Water on earth is there, and 97% of water on earth is there, okay, is in the form of oceans and seas. 97% of whatever is present is in the form of ocean and seas. And now we are able to see that 3% is nothing but fresh water, okay. Out of 97%, if it is ocean water and saline water, only 3% is nothing but fresh water, okay. Fresh water is present in the form of rivers, lakes, and streams and swamps. Here we are able to see that the 3% of fresh water. This is nothing but 3% of fresh water. And that side is given here. Okay, it's 97% is ocean water, and fresh water is nothing but 3%, and the glaciers is nothing but 70%. This is nothing but glaciers. 70% of it is glaciers. Okay, this is nothing but glaciers. And underground is nothing but 29% is underground, and rivers and lakes is less than 1% is rivers and lakes. Like that it is. Okay, now let us very important. We have studied whatever slides we are seeing. It's very important. Now let us go to the next slide. Here we are able to see that impurities that are present in water. So natural water is usually contaminated by different types of impurities. Okay, very important. Natural water is there. We are having natural water. We are having that our natural water is there, and it is usually contaminated by different types of impurities. Okay, so what are the different types of impurities that is being contaminated by the natural water that is present on our earth? Okay, very important. So we are seeing that natural water is present, and the three main types of impurities is nothing but physical impurities, chemical impurities, and biological impurities are there. Physical impurities are there, chemical impurities are there, biological impurities are there. Okay, what is meant by physical impurity, chemical impurities, and biological impurities? We will see. Physical impurities are there, color is there, turbidity is there, taste is there, odor is there. Okay, these are all nothing but the physical impurities. Color, how color is causing physical is responsible as a physical impurities. Color is being responsible as physical impurity because of the presence of metallic substances, like various kinds of salts are present in water, and these various kinds of salts that are present in water is responsible for the physical impurity, that is nothing but color of the water. Physical impurity, it's a physical impurity. It's causing unnecessary color. Chromium and manganese might cause unnecessary color in water, and this unnecessary color present in water is a part of physical impurity. Now, turbidity is there. Turbidity, how turbidity means finely divided clay and slit. Slit is unnecessary finely divided clay, and microorganisms are responsible or being responsible for the turbidity of water. And this especially finely divided clay will form a colloidal suspension in water, and this finely divided clay, this colloidal whatever form is present in water, this is responsible for turbidity in water. Okay, this is called turbidity in water. Now, taste. What are the things that are responsible for taste? Okay, very important. Taste. Unnecessary is salts like iron, aluminium, manganese, sulfates, and lime. All these are unnecessary material. Okay, they are causing a bitter taste in water, and they are responsible for the physical impurity, because they are causing bitter taste for water. And unnecessary sodium bicarbonate, if it is dissolved, then it is causing soapy taste, and the soapy taste is also responsible for causing is also a physical impurity. Now we are seeing that odor is there. Okay, odor is there. Now odor is unnecessary odor. What is unnecessary odor is nothing but industrial purpose. What is undesirable for domestic as well as industrial purpose. Okay, like that we need to remember all these things. We need to properly remember what is meant by what is how it is causing different kinds of odor, color, taste, turbidity, and taste. Okay, odor is caused by undesirable domestic and as well as industrial purpose. Whatever has been discarded from a domestic and industrial purpose, that is causing unnecessary odor. Now, what are the chemical and biological impurities? We can see here chemical impurities. Chemical impurities is nothing but inorganic chemicals like cations are there. Okay, cations like aluminum, calcium, magnesium, iron, zinc, copper, sodium, potassium. All these are inorganic cations. Okay, inorganic chemicals, chemical impurities that are being inorganic chemicals that are responsible for chemical impurities. Okay, anions are there: Cl minus, SO4 2 minus, and NO3 minus, HCO3 minus, F minus, and NO2 minus. All these are responsible for chemical impurities. Okay, all this aluminum, calcium, magnesium, and iron 2 plus. All these are responsible for hardness causing salts. Okay, all these are responsible for hardness causing salts, and SO4 2 minus and NO3 minus is also HCO3 minus is also responsible for hardness causing. Okay, so that's why they come under chemical impurities. Physical impurities, all physical, whatever we can see and whatever we can experience are nothing but physical impurities. Color is there, then odor is there, then the finely divided clay and microorganisms that are biological microorganisms, some kind of microorganisms that are present come under physical impurities. Chemical impurities, nothing but all chemical agents that are responsible for different kinds of salts and different kinds of pesticides and organic dyes, paints, petroleum products. Here, so these are nothing but inorganic chemicals. Okay, aluminum, calcium, magnesium, very important. Inorganic. These are all inorganic, and now organic chemicals are also present, which are part of chemical impurities. What are the organic chemicals that are part of chemical impurities? Dyes, paints, petroleum products, pesticides, detergents, drug textile materials, other inorganic related materials. So all these are what is called as what we are able to see, what is called as what we are able to see, and what is called as organic chemicals. Okay, very important. Dyes and paints and petroleum products, pesticides and detergents, drug textiles, materials, and all these are organic related materials that are impurities, organic impurities. Okay, which are part of chemical impurities. Now let us go to biological impurities. What are biological impurities? Algae. Okay, green matter that is present on stagnant water, algae. Okay, that is nothing but algae. Then pathogenic bacteria, disease causing bacteria, then fungi, then viruses, pathogens, parasitic worms. All these are nothing but biological impurities. Very important. Biological impurities, chemical impurities we have to remember, and biological impurities we have to remember. Okay, these are all the impurities that are causing that are damaging our water that is present on earth, and we need to take care of the water that is present on earth. Okay, now let us go to the next slide. This slide talks about hardness of water. Okay, this hardness of water is related to water causing water not causing proper lather with soap. Okay, because of the presence of, so here we can see first point, hardness of water defined as which prevents the lathering of soap. Okay, whatever water which does not cause lather with soap is called as hard water. Suppose we are taking bath with the river water. When we are taking bath with the river water, what is happening when we are taking bath with the river water? We are taking bath with river water, and we are producing nice lather on our body. Okay, on the other hand, when we are taking bath with underground water we are taking bath means when we are taking bath with underground water, it will form curdy white precipitate when we are taking bath with underground water. That is because why it is forming a curdy white precipitate when we are taking bath with underground water. Very important, it is causing curdy white precipitate when we are taking bath with underground water. It is because of the presence of calcium and magnesium salts, okay, and other heavy metals that are dissolved in water. All these ions will react with soap, and it forms a white precipitate. What is that white precipitate, how it is formed, that we will be seeing in our next class. But currently we just need to remember that it is forming a curdy white precipitate, Ca2 plus and Mg2 plus. Now, here we are able to see that soft water is nothing but water which is forming proper lather with soap is called as soft water, and hard water is nothing but water which is forming unnecessary salts, unnecessary water which is forming curdy white precipitate with soap is because of the presence of calcium and magnesium salts and other heavy metal ions is nothing but hard water. Okay, all right. Okay, thank you, students. Thank you for listening. Thank you for your patience. In our next class, we will see what is hard water and what are the units of hard water. Okay, thank you very much.